Working on section 9.4, we're dealing with simplifying rational functions. So this is sort of the beginning step into multiplying, dividing, adding, and subtracting rational functions, because simplification is part of the steps, one of the steps in each of those processes. So the three things you need to do in order to simplify rational functions are factor the numerator, factor the denominator, and cancel common factors. So let's address these problems. If I want to factor x squared minus 2x minus 3, I know that with this sign, a minus, that one of these is a plus and one of them is a minus. And then I want factors of 3 that have a difference of 2. Well, that's 3 and 1, and the 3, the larger factor, goes with the minus sign. So we've factored the numerator. Now we're going to factor the denominator. This plus sign here tells me that the signs are the same. This tells me they're both minuses, so I know I have x minus, and now I want factors of 12 that will add up to be 7. That's going to be 3 and 4. So I factored the numerator, factored the denominator, and now I will cancel the common factors. X minus 3 is common to the numerator and the denominator, and if I write this in a simplified form, x plus 1 over x minus 4. Moving on to this particular problem, I can factor a 3 out of the numerator here. This is 3 times x squared minus x minus 2. If I factor this quadratic equation, the minus tells me that the signs are different. So one's a plus and one's a minus. And I want factors of 2 with a difference of 1. That's 2 and 1. The 2 goes with the minus sign. And in the denominator, this is the difference of 2 squares. That's x plus 2 times x minus 2. If I cancel common factors, I cancel the x minus 2's, and I end up with y is equal to 3 times x plus 1 over x plus 2. Okay, so these are fully simplified. So that's simplifying rational functions. We do that so that we can proceed and do multiplication, division, and it's the final step in addition and subtraction as well. So here we're working on multiplying, and remember we're going to multiply numerator times the numerator, the denominator times the denominator. But key in this is to simplify before you multiply. Now, I can also simplify across fractions that are being multiplied. And you'll see in this first problem, I have 3 different types of items. I have integers, I have x's, and I have y's, and I'm going to address them one at a time. So 5 goes into 80 16 times. I have x squared down here. If I take the x squared out of x to the 4th, that's going to leave x squared. I have 1y here, and if I take that y out of y cubed, that's going to be y squared. And now I've fully simplified. Now I can multiply. So I have 16x squared times x. That's 16x cubed. And in the denominator, all I have is y squared. Okay. In this particular problem, I want to simplify before I multiply, so I want to factor everything. This is 2 times x squared minus 5 over x plus 1 times x plus 2, and I can factor a 3 out of this. 3 times x squared minus 5. And the x squared minus 5's cancel. And what I'm left with is 2 times x plus 2 over 3 times x plus 1. Okay. When we're dividing, it's very similar to multiplying, except we have one extra step. We need to invert the fraction that's going to be after the division sign. So I need to invert these two fractions and turn it into a multiplication problem. So it becomes times the inverse of that fraction. And now it's a multiplication problem, and we just learned how to do that. 2 goes into 6 3 times. The 3 cancels with the 3. This x cancels with one of the two. This x cancels the other one. I have 2 z's in the numerator, 2 z's in the denominator. And I have 1 y in the numerator, and I have 3 in the denominator. That's going to leave 2. So my final answer is y is 1 over y squared. Okay, if I work on this problem, I'm going to invert this fraction, but I'm also going to factor the numerators and the denominators at the same time. This is the perfect square of a binomial, right? X squared is the square of x, 16 is the square of 4, and this middle term is 2 times x times 4. So that's how I recognize the pattern. So this is x plus 4 squared over x plus 2. And this is the difference of two squares, right? This is x squared minus 2 squared, so this is going to be x plus 2 times x minus 2. I'm inverting the fraction, so I move it to the numerator. And when I factor this item, it's going to be down here on the denominator. The plus tells me my signs are the same. They're both pluses, so I have x plus, and I want factors of 8 that add up to 6. That's 2 and 4. Now I want to cancel my common factors. So I have x plus 2 and x plus 2. I have x plus 4 here, and I have 2 of them there, so I cancel out one of them. And what I'm left with is x plus 4 times x minus 2 over x plus 2. And we're done. Okay, sometimes you'll combine these operations together in the same problem. Just remember, anything after the division sign needs to be inverted. Also, to make sure that I stay clear of what's in the numerator and what's in the denominator, I'm going to add denominators of 1 in my items that aren't fractions. So I'm going to invert this, x squared plus 7x plus 12 over x squared minus 11x plus 30 times x minus 6 over 1. When I factor this middle term, x minus 5 over 1, my signs are the same. They're both pluses, so I have x plus and x plus. Factors of 12 that add up to 7, those are 3 and 4. And here my signs are the same, but they're both minuses. X minus, x minus. Factors of 30 that add up to 11, those are 5 and 6. Okay, now I've factored everything, and I want to cancel common factors. X minus 5 cancels with x minus 5. X minus 6 cancels with x minus 6. And I'm just left with y is equal to x plus 3 times x plus 4. Everything in the denominator ended up being 1. And that's my solution. Again, if I have multiple operations, I'm going to invert that fraction. I'm going to invert that fraction. I'm going to go through this, and as I do the inverting, I'm also going to factor. So this tells me my signs are different, plus and minus. Factors of 12 with a difference of 1, that's going to be 4 and 3. 4 goes with this sign, the minus sign, over 8x squared, times. Now when I factor this, I can factor a 2x squared out of each of these terms, and that's 4x minus 1. When I factor this one, I can factor an x squared out of each term. That's x squared times x plus 3. And when I invert this, there's no factoring to do. It's already factored. I like to put parentheses around my binomials, even when they're alone in the numerator, just to keep clear about these things being the whole entity is a factor. X is not a factor, 2 is not a factor, but the quantity x plus 2 is. If I go ahead and cancel common factors, I can cancel 4x minus 1 with 4x minus 1, x plus 3 with x plus 3. 2x squared goes into 8x squared 4 times, and that's fully simplified. So now when I multiply numerator times numerator, I'm going to get x minus 4 times x plus 2 all over 4x squared.